Now we will discuss about the particles of matter are constantly moving. As we know, the particles of matter are constantly moving. Now we can take some activity related to this to prove it that the particles of matter are constantly moving. The best evidences for the existence and movement of particles in liquids was given by Robert Brown. Robert Brown is the name of scientist which discovered the Brownian motion. Robert Brown in 1827. Robert Brown suspended extremely small pollen grains in water. On looking through the microscope, it was found that the pollen grains were moving rapidly throughout water in a very irregular motion. Robert Brown suspended extremely small pollen grains in water. On looking through the microscope, it was found that the pollen grain particles were moving rapidly. Pollen grain particles moving rapidly throughout water in a very irregular manner or in zigzag way, just like this. That is very irregular manner. Now we can draw the diagram related to this experiment. Suppose we take a container and fill this container with water. Suppose this is the particles of water, and now we add some pollen grain particles in this water. Here pollen grain particles behave like a solute. Pollen grain behave like a solute particle, and these water molecules or particles of water behave like a solvent particles. And now we use microscope and we see that the particles of pollen grain moves in very irregular manner. Suppose the particles move in this direction, it strike with this molecule of water and change its path in this direction, and now it runs in straight path and strike with this molecule of water and change its path. Now it goes in this direction and change its path by striking this molecule of water. Now it runs in this direction and strike with this molecule of water, now change its path. So we can say that these particles of pollen grain strike with the particles of solvent, here that is water, and change its path, and it becomes in very irregular manner, means the motion of the pollen grain particle is just like this, very irregular manner, not in any easy path or straight path, just like this. So we can say that the movement of pollen grain particle is very irregular, or this zigzag motion is known as Brownian motion, because it was discovered by Robert Brown. So we can define Brownian motion. Brownian motion. Zigzag or very irregular motion of particles is known as Brownian motion. The movement is due to a collision between solute and solvent molecules. Now we can say that the Brownian motion is due to collision between solvent and solute particles. In the case of pollen grain activity, the Brownian motion of pollen grain particle is due to collision of pollen grain particle with water molecules. Because water molecule is a molecule of solvent and the pollen grain particle is a molecule or particle of solute. Brownian motion is also observed in gases, and we can take example related to this. Sometimes when a beam of light enters a room, we can see tiny dust particles suspended in air which are moving rapidly in a random way. Suppose this is a particle of air. These are particle of dust, and dust particle mixed with air. These particles strike with this particle of air and change its path. Now it is strike with this particle of air and change its path. Now it strike with this particle of air, change its path. So we can say that the particles of dust moves in very irregular manner. So this is also an example of Brownian motion. Now we can take another form phenomena which related to constant moving of particles of matter, that is diffusion. Diffusion. We can define diffusion. Intermixing of particles of two different types of matter on their own is called diffusion. Intermixing of particles of two different types of matter on their own is called diffusion. Or we can say that the phenomenon in which the movement of molecules or particles occur from their higher concentration towards their lower concentration is also known as diffusion. The phenomena in which the movement particles occur from their higher concentration towards their lower concentration. It is also known as diffusion. We can take some example related to diffusion. The example is that when a perfume bottle is opened in one corner of a room, its fragrance spread in the whole room quickly. Suppose this is any bottle of perfume, and this is a particle of perfume inside the bottle. As we open the cork of this bottle, these particles spread from inside to outward direction, because the concentration of particles of perfume is higher inside the bottle, and initially the concentration of particles of perfume outside the bottle is zero. So we can say that this is a lower concentration field for perfume with respect to particles of perfume. So the particles of perfume spread from higher concentration to lower concentration. So this phenomena is known as diffusion, because the movement of particles from its higher concentration towards their lower concentration is known as diffusion, and this is a diffusion of perfume. Or we can say that here in this environment the particles of air also present. This is a particle of air. When we open the cork of this bottle, we see that the particles of perfume intermix with the particles of air on their own. So we can say that the intermixing of particles of two different types of matter on their own are also known as diffusion. And also the particles of air also intermix with this portion of perfume. So we can say that the particles of air intermix with the particles of perfume, and the particles of perfume mix with particles of air. So this phenomena is known as diffusion. And we feel the smell of perfume in at every place near this bottle of perfume. So we can say that the particles of matter are always constantly moving. If they are not moves, so here we shouldn't feel the smell of perfume. But we feel the smell of perfume, it means we sense the uh, we sense the smell of perfume. So we can say that the particles of matter are constantly moving. Now the next point, the next property of particles of matter. Particles of matter attract each other. Particles of matter attract each other by some types of forces, and we can classify forces in two categories. First one is cohesive force, and second one is adhesive force, and both are force of attraction which bind the particles of matter. Now firstly we define cohesive force. The force of attraction between the particles of same substances is called cohesive force. The force of attraction between the particles of same substance is known as cohesive force. Is known as cohesive force. Now we can take some examples related to this. Suppose this is a chalk, and it's a particle of chalk. The force of attraction which works between in these two particles of chalk is known as cohesive force, and the direction of these forces towards each other. We can enlarge it. Suppose these are two particles of chalk. This particle of chalk attract this particle, and this particle of chalk attract this particle in this direction. And this is a force of attraction between the particle of same substance, and this is known as cohesive force because both particles is a particle of same substance. So we can say that the force of attraction which works between the molecules or among the molecules of chalk is known as cohesive force. And we can take another example. The force of attraction which works between the molecules or the particles of water is also known as cohesive force. Now we will be discuss about the adhesive force. Adhesive force is also a force of attraction, but it works between the particles of different substances. So we can define it: the force of attraction between the particles of different substances is called adhesive force. Now we can take example related to this adhesive force. Suppose we use any glass. Suppose this is a glass, and fill this glass with water. It's a particle of water. The force of attraction which works between these two particles of water is known as cohesive force, because cohesive force works always between two molecules or two particles of same substance. And suppose this is a one particle of this glass and this is a another particle of this glass. So the force of attraction that works between these two particles of glass is also known as cohesive force, because these particles are identical or particle of glass. So we can say that the force of attraction which works between two particles of same substance is known as cohesive force. But the force of attraction which works between this molecule of water and this molecule of glass is known as adhesive force, because it works between two different type of particles or a different type or particles or different type of substance. So we can write it like this is a particle of glass and this is also particle of glass, and this is a particle of water and this is a particle of water. So the force of attraction which works between these two particles of water is cohesive force, and the force of attraction which works between two particles of glass is also cohesive force. But the force of attraction which works between these two molecules, in which one of them is molecules of water or particle of water and another one is particle of glass, and this attraction force is known as adhesive force, because it works between two different type of particles, and the force of attraction it is cohesive for two particles of two identical particles.